What we have here is a Lux Blox model of the arrangement of carbon atoms in a diamond. I have these blocks different colored here so that they represent one carbon atom, but you can see that they are connected together in a network, and each intersection of these lines represents the location of a carbon atom that's tetrahedrally bonded to a different carbon atom. Now, the configuration of all of these carbon bonds along each of these bonds is staggered, and you can see that the bonds are arranged in hexagons, like down here and here and here and here, but none of the hexagons really line up on top of each other, and this gives diamond what we refer to as a cubic symmetry. Now, there is another form of carbon. Some people call it hexagonal diamond. It's pretty rare, formed under exotic conditions, but it has this sort of arrangement like this, where there are hexagons stacked on top of hexagons, and the bonds have a combination of staggered and eclipsed geometries. But there's a hexagonal symmetry in this overall structure, hence it's called hexagonal diamond. It's also called Lonsdaleite because it's named after Kathleen Lonsdale, an Irish crystallographer. Now, there are other structures that have cubic and hexagonal symmetries. For example, water ice. So here's a representation of a water molecule where the red blocks represent an oxygen and the white blocks represent hydrogens. And the most common form of ice here on Earth is ice 1H, where H stands for hexagonal symmetry. And as you can see, this resembles a hexagonal diamond, and that you have a combination in these water molecules that are covalently and hydrogen bonded together. You have combinations of staggered and eclipsed conformations. So this is a pretty common form of water. In fact, there's a connection to the macro scale. One of my favorite books is called Snowflake Bentley. It's about Wilson Bentley, the first person to really photograph snowflakes. And he put together a book of pictures of snowflakes and published it, and there's a copy of that book. You see all these snowflakes have hexagonal symmetry, and the visible six-fold symmetry of snowflakes here is a result of six-fold symmetry, the hexagonal symmetry, resulting from the bonding of water molecules to each other. Now, there is a rare form of ice called cubic ice, and what I can do is I can offset these hexagons like this, and turn it like this. Offset the hexagons and sort of hold the structure together with my hand here. But what we can see here is we're back to that cubic symmetry like we saw with the diamond. But again, I want to reiterate that this is a rare form of ice.